So hi guys, I hope all of you are doing fine. Welcome to my YouTube channel. Today in this video we are going to set up our Linux system to do some machine learning. So there are many tools, libraries and frameworks out there to create and train machine learning models. However, many who are just starting out in the field are largely unaware of the various awesome libraries and frameworks which are already out there. So in this video we will briefly get to know those tools and see how to install them. So let's get started. So one of the first question which we all face when we are starting out is which programming language to pick for data science and machine learning. This is a very subjective question and may depend on person to person, but from the machine learning point of view, few of the major languages for machine learning are Python, Java, JavaScript, and there is new language which is Julia learning. However, I will be talking about Python language and its ML ecosystem in this video. This is primarily because of the very good community support, documentation, and the rich libraries and framework that already exist for creating machine learning applications in Python. So to install the Python, we will use a virtual environment. First of all, a great question to ask is why use a virtual environment or not just the Python which comes already installed on most of the Debian slash Linux system, also called as the system Python. To answer that simply, in a Linux system, the system Python is used by various users and system applications, which may depend on certain version of a library. If we install a newer or a different version of the same library, it may break the user or system application and may jeopardize the OS. So I have personally experienced this and hence always recommend using a virtual environment for your Python projects. Now, coming back to the question, what is a virtual environment? It is basically an isolated and standalone copy of the Python interpreter and all of its dependent packages. Any package can be installed slash uninstalled without any root permission or breaking the functionality of any user or system app. More than that, it also allows different Python versions and libraries to coexist in the same system. I personally use separate virtual environments to maintain the different Python versions and all of the dependencies of each Python project. So the virtual environment that we will be using is called as Conda. So there are actually two versions of the Conda. One is Anaconda, which is basically a full-fledged installation of most of the data science and machine learning libraries. I don't personally like it as it takes huge amount of space and none of my single project ever used all of those installed libraries. Moreover, it takes a hell lot of time to install that particular version of the Conda. Another version of the Conda called as miniconda is what we will be using to install the Python. As the name suggests, the miniconda is basically just the basic Python interpreter with the standard packages. Once the miniconda Python installation is done, we can install most of the required libraries on top of. So let's head over to the website of the miniconda to get the installer. To get the installer, you can just type miniconda in the Google and the first link will navigate you to the miniconda web page. Once we reach there, you can see there are the installers for Mac operating system, Windows and Linux. Since we are interested in Linux, we can just get the installer for that. So the miniconda maintains the latest Python installers. So we will be downloading the Python 3.8. To if we just click the 64-bit, it will download the installer for 64-bit machine. If you have a 32-bit machine, you can just download it for 32-bit. Once the installation is done, head over to the terminal. As we can see, we have the miniconda installer here. In order to install, what we have to do, we just need to type the bash and give this file, give this miniconda bash file as an input. So now it will ask the press enter to continue. And here you can just type Q, which will navigate you to the end of the agreement, and then you have to accept the license term. Now it will ask you for the default location or the default root location for the installation. In my case, I'll installing in my home directory under a miniconda folder. So based upon the speed of your machine, it might take some time. So now at the once the installation is done, the miniconda installer will ask you to set this miniconda as your default Python installation. I prefer I to select as a no because I don't want to mess up the system Python. So once the installation is done, in order to activate the virtual environment or the Conda environment we just installed, you need to type source and give the path to the give the root path of the installer. In my case, it's my home directory and the miniconda folder. Once you are at the root directory, you have to navigate to the binaries and the activate. So once you run this command, you will see that you're now in a shell which says you are in the base environment, which says basically you are now in the Conda environment whose name is base. So by default, the Conda environment name is the base environment. So now if we type Python here, we can see we have the Python as per what we have downloaded from the website. And it is also from the Anaconda Inc. So now to get out of or deactivate the Conda environment which in which you are currently in, you can just type the Conda deactivate and you will get out of that particular environment. Now let's switch back to the our base environment again and let's create a new environment. In order to create a new environment, all we have to do is use the conda create command. So with the create command, you have to pass in the Python version we want to use. Let's say in our case, this time we want to use a Python 3.7. And let's give a ML environment as the name of this environment. Once we do that, the installation of the Python 3.7 will take place. Once the virtual environment is done with downloading the file and installation, you can activate the Conda environment in the similar way we activate our base environment. However, this time we don't have to pass the whole path of the base environment, a whole path of the environment as compared to the base environment. Yeah, so yeah. So as you can see now, now we are in the ML underscore environment. Now if we type the Python here, you will see the Python version is 3.7 as compared to 3.8, which was the base version of the which was the Python version of the base environment. So again, to deactivate or get out of this environment, we can just type conda deactivate. One of the important feature which we need to know is basically the conda environment list, which spits out all the environments currently are in the base in this base environment. As we can see, the base itself is the one of the environment and the another ML environment which we just created. Now sometimes if we have many multiple environment, we want to delete those environment. To delete a conda environment, we just need to type conda and type environment delete not delete remove one hyphen name and the environment we want to delete. So this will delete the entire environment. And now if we look at the conda environment list, you should be able to see only one environment, which is the base environment. So now let's talk about some of the basic machine learning libraries which we use to do many machine learning projects. So this is not a comprehensive list in any manner. These are just the basic libraries which every machine learning practitioner should be aware of. So NumPy is one of that. So NumPy basically has the multi-dimensional array support, which is not natively supported by the Python. So the another library which is the pandas basically provides this concept of data frame which allows to manipulate the larger data sets very easily. Another important library in ML is the matplotlib, which is widely used for plotting purposes in Python. And the another library, which is the holy bible for the machine learning in Python, is the scikit-learn. So scikit-learn library is contains various implementation of the many machine learning algorithm, and it is very well documented. So now let's head over to our environment which we created, and let's see how we can install this library. As you can see, now we are in this ML environment which we just installed. Now to install the libraries, we just need to use the Python package manager, which is the pip. So pip is like any other any other package manager. So you just need to type pip and pass in the library which you want to install. So in our case, it's numpy, pandas, matplotlib, and the scikit-learn, which is basically the sklearn. So as you can see, once we type this library, the package manager will automatically figure out all the dependencies and the required versions of the library and fetches it from the PyPy repository and installs them for you. Another important feature for the pip package manager is sometimes we need to install a certain library version. To do that, while giving the install command, we just need to pass in the library version which we are interested in. Now to confirm whether these libraries has been installed, let's open a Python terminal and import all of these libraries and try to print their version. So the numpy is working as expected. Reported, which shows that the library installation was successful. Now let's try to import the sklearn. Yeah. So So if we are trying to do the deep learning in 2020, there are many deep learning frameworks out there, and mostly every tech company, every major tech company has their own deep learning framework. So sometimes it becomes a kind of a confusion for a newbie to understand which deep learning framework is more suitable. So the two widely used DL frameworks in the communities are basically the TensorFlow and the PyTorch. The TensorFlow is created by the Google, whereas the PyTorch is by the Facebook AI. The main difference between the TensorFlow and PyTorch is that the TensorFlow is based on static graphs, which basically means that the operation which we want to do in a neural network needs to be first defined in the form of a computation graph. This computation graph is then first compiled, and then the computation is spread across the available compute devices. Whereas in PyTorch, the computation or the order of the computation is defined by the user, and it is adapted on the fly as compared to the static graphs. So now let's head over to the one of my GPU machine where we'll see how to install this TensorFlow GPU. So the TensorFlow CPU is pretty easy to explain, is pretty easy to install as compared to the TensorFlow GPU, because in TensorFlow GPU we sometimes need to install the Coda toolkit. However, if we use the Conda environment, it becomes pretty simple. So let's first of all create again a Conda environment for installing the TensorFlow, which you don't need to do, but in my case I prefer it to keep the TensorFlow in a particular environment. Once the environment is created, let's get into the TensorFlow environment. Now in order to install the TensorFlow GPU, what we need to type is basically use the what we need in order to install the TensorFlow GPU. What we can use the Conda installer instead of pip. The Conda installer has a very good channel and a Conda which maintains all the dependency and is being updated regularly. So let's use that to install the TensorFlow GPU. So since the installing TensorFlow GPU required installing the CUDA toolkit and various other OpenCL and OpenBlast libraries, so this might take a long time. So just be a bit patient about this. Now the installation has done. Let's verify whether the TensorFlow detects any GPU or not. So let's start a Python interpreter and import this device lib, which basically help us to give the count of all the compute devices we have to run the TensorFlow. As you can see, in my case, I have basically two GPUs, hence it is showing two devices. And so device 0 is again GeForce RTX 2080 Ti, device 1 again 2080, because my system has two 2080 Ti's and one CPU device. Now just to verify, if I type NVIDIA SMI, you can see that I have two GPUs, and this shows that our TensorFlow installation is working fine. To install the TensorFlow GPU is pretty straightforward. If you just want the TensorFlow GPU, instead of using the TensorFlow GPU, you can just type TensorFlow and that will just install the CPU version of it. However, if you install TensorFlow GPU, it will install the support for CUDA libraries and all the required toolkit, and you will be able to use both CPU and GPU in this case. Now to do the PyTorch installation, the best way to install the PyTorch is basically from their website. So let's head over to their main website, which is pytorch.org. Once we reach to the pytorch.org, if we just scroll down, they automatically creates a command for you based upon what is your Conda environment is or your package manager is. So let's say we want to get the more stable release, and you can select your operating system and your package manager, in our case which is Conda, and the language and the CUDA toolkit. If you want the higher version of the CUDA toolkit, you can select appropriately and your command will change here automatically. So all you need to do is basically just copy this command and put this into your required Conda environment, and that will install the PyTorch into your system. So the one more tool which is typically used, and it is really useful for doing machine learning, is the Jupyter notebook. So, so let's first of all have a look at how to install the Jupyter notebook. For that, I'm going to switch back to my old ML environment. One another important tool for doing the data science is Jupyter Notebook. The Jupyter Notebook allows to do interactive computing as compared to the normal Python coding. In normal Python code, we typically write a script which is executed by passing it to a Python interpreter. Once the script execution is done or it fails, it abruptly exits the interpreter. However, with the Jupyter Notebook, you can basically put your code inside a cell section and execute it, and it will not still exit the Python interpreter. This becomes really helpful when we are dealing with larger data sets in machine learning or data science. So let's head over to the ML environment which we created to see how to install the Jupyter notebook. Install the Jupyter notebook, we will again use the pip manager. However, before installing the notebook, we have to install the Jupyter core. Once the Jupyter core is installed, we can install the Jupyter notebook by passing it to the pip package manager with install command. Oh, since now the Jupyter notebook has been installed, to launch the Jupyter notebook, we first have to create a Jupyter server. So let's create a Jupyter server in my download folder itself. To start a Jupyter server, we just need to type Jupyter notebook, and optionally you can also provide the IP. By giving an IP as 0.0.0, you are basically allowing all the local machine to access the server. Once we do that, it will generate a token that you need to copy every time when you are trying to open this Jupyter notebook link. So if you are opening on the same machine, it will automatically get the token. However, if you're trying to access this server from another local machine, you have to send copy this token and paste there. So as you can see, I have started a Jupyter Notebook server in my own download folder. To create a new Jupyter Notebook, you just need to go to the new and select Python 3. It will create a Python notebook there. You can give a title to it. Okay. Now each block in this notebook is called as a cell. The cell allows you to basically execute the code in a piecewise manner. So I hope this video might have helped you to get started with setting up the machine learning environment in a Linux system. So this is my first video on YouTube, and I will be uploading more content regarding the machine learning, and I would love to know what you would like to see in my future videos. So please drop a like, share and comment, and please consider subscribing my channel. Thank you.